Let's start in 10 seconds. Sure. Okay, let's start. All right. So good evening, everyone. So welcome to our monthly APOD presentation held by Astronomical Society of Penang. So yeah, to all our beloved audience. So very nice to meet you all again because I've been disappeared for quite some time. And yes, I'm back this month. And together with us tonight, we have Dr. Chong, President of Astronomical Society of Penang. He's the presenter that always appear in this APOD session. Right? And then we have our flower of ASP, right, Miss Chu Boon Wei. She's also our assistant secretary. Right? And then she has just changed her job and she was back in Silterra in Kulim. And she traveled weekly and she especially traveled back to Penang with us to present the APOD tonight. So yeah, she want me to mention this that she is 20 this year, right? Yeah, I was forced to say so. All right.
Hey,
All right. And then also tonight with us, all right, we have our old friend, Sunit Singh. He's our member, a member of Astronomical Society of Penang, and currently actively participate or join us with our outreach program. And he just finished his A level in college and applying to university. So once again,
Mr. Lai, introduce yourself.
yeah, I'm Lai. Sorry, yeah, I'm Lai. Have disappeared from this APOD session for quite some months. And then I think the last time I present was last October, I guess, if I'm not mistaken. October or September. It's quite some time. Right. And yeah, I'm a committee member of Astronomical Society of Penang. And as usual, right, we will start with today's APOD. So before we start with today's APOD, our dear audience, if you all have any questions, all right, feel free to interact with us through the comment section in the Facebook page, all right, or the chat box on the YouTube channel. So let's begin with today's APOD, 26th of February, right? So let me share today's APOD. So today's APOD is actually the moon, all right. The moon is not the moon on Earth, right? It's not the Earth moon, but is the Saturn's moon called Iapetus, right? It's a moon with a strange surface, right? This moon is big, right? It's very big. Is the third largest moon of Saturn and the 11th largest moon in the solar system. Of course, the largest moon in solar system is not our moon that we see on Earth, right? It's the moon of Jupiter. All right, the largest one is Ganymede. And our moon, all right, the moon, the Earth moon is the fourth largest one, I guess. I think, yeah. And this is the Saturn's moon, all right, the third largest one called Iapetus. This actually is an old image. It's not a new photos or recently captured. All right, it's captured at the end of 2004. 2004. And as you see, this, all right, I slightly strange the image. All right, it's a big moon, but then it's not round. All right, it's not circle or it's not also it's not even an ellipse. All right, something special about this moon is the ridge over here. All right, the ridge over here. Okay, we can see there's a clear ridge on the equator. All right. So this is what caused this ridge until now is still remains unknown. Scientists are still studying what caused the ridge to form over the equator of Iapetus. These Iapetus have a diameter about 1,470 kilometers and is the 24th of out of the 83 known moons of Saturn. So Saturn have a lot of moons, all right. Until now, we have discovered about 83 moons confirmed, and this is the 24th. And this image is actually taken by the Cassini spacecraft. All right, Cassini spacecraft is launched on many years ago. I think around somewhere on 15th of October 1997, and the mission it take about 6 years to reach, more than 6 years, right? 6 years and 8 months to reach Saturn. So it reached Saturn, and then it starts the mission. All right. So it studies Saturn. It studies the Saturn's natural satellites. So this is the image taken by Cassini. And this Cassini, something interested about this Cassini is the mission have ended in 2017. All right, it burns up. All right, it travels into the Saturn's atmosphere and it burns up in the Saturn's atmosphere. Someone actually questioned why we want to let Cassini to burns up in this Saturn atmosphere, but not land on some moons or some moons that in the habitable zones, or we suspect that moons of the Saturn that are habitable. The reason is actually quite simple, because we don't want to contaminate the so-called habitable or suspected habitable or potentially habitable moons of Saturn. So we let it burn up in the Saturn's atmosphere. And something interesting about this Iapetus is, if you realize, all right, there's a big crater over here. All right, and this crater have the diameter of approximately 400 kilometers. And another interesting thing is, like, the Iapetus, right? The Iapetus is not round. All right, someone mentioned that they actually have the shape like a walnut, right? It looks a bit like walnut. All right, it's irregular shape, and surprisingly, is a big moon. And the dark part over here is actually very dark, it almost invisible, right? And the bright part is very shiny. And this is actually an ice body. That means most of the surface is actually ice. All right. So this is more or less about Iapetus. So I'll pass over to Sunit to continue the presentation, and I'll continue again later. So Sunit.
Yeah, hello, good evening, everyone. So, right now we presenting my four pictures, right? All right. So let's present. Right. Can you see my screen?
Yes. Can
Okay.
see you also.
So this is the APOD picture for the 22nd of February. So which is about the picture of our sun, and the title our increasingly active sun. So as we all know that for all the people who keeps taking photos of the sun, we know that these few years, right, the sunspot, or we can say the activity of the sun, is getting more and more intense. It's increasing as we are speaking right now. So because there's this thing called solar cycle, which means that in every 11 years, the sun will go through a series of solar activity cycle, which means that in 11 years, the sun will increase with maximum activity, and then it will decrease to its lowest activity, which means that currently our sun is getting more active for now, and it will hit the maximum activity in about 2 years. So we're expected to see a lot of prominent sunspots in these few years. And after that, after these 2 years, our sun will start to decrease in terms of the activity. The activity will decrease in about 5 years. And so, like, after 7 years from today, the sun will be very, very inactive. And then the cycle will keep on going. So, after the sun gets inactive, it'll get active again and inactive. You'll see a lot of sunspots in one day. And then maybe after 5 or 6 years, you'll see nothing at all. So, this picture is taken by Mehmet Ergin, which is a Turkish astronomer. Sorry, it's not astronomer, it's an astrophotographer. So in this image, we can see there's a lot of prominence around the sun, and also some filaments on the surface of the sun. So these filaments are also the prominence of the sun. So you can see that this particular image of the sun is showing us that the picture when the date of this picture was taken, the sun was very, very active. And you can see that there's a lot of sunspots. There's one over here, one over here, one over here, a big patch of it over here, and you can compare the size of the sunspot to our size of the Earth, which is so small that some of the sunspots here are they can fit like maybe 3 or 4 Earth inside it. And the reason of this sunspot, why do they appear black or darker than the surface of the sun, is that the magnetic field around the sunspot, around these areas, and also the prominence, are much more higher compared to other surface of the sun. So you can see that the sunspots appears to be more darker, and also that because the temperature of the sunspot there is quite lower compared to the surface, which is like, so for example, the temperature over there is maybe like 3,000 to 4,000 Kelvin, but the surface of the sun, the temperature of the surface of the sun is like 5,500 Kelvin, or 5,000 plus degrees Celsius. So this is it for this picture. Then I'll present the next one. Okay, the 19th February. So this image, so we when okay, actually my first thought of looking at this image, I thought that it's just a nebula and so pretty, but actually it's not a nebula. So it's quite surprised that I will tell you that this is not a nebula, but it's actually a open star cluster, a famous one actually, and it's called the Pleiades M45. So you can see the title here, 7 Dusty Sisters in Infrared, which means that Pleiades, which is also we call the 7 Sisters, and this image is taken in the infrared wavelength. And why we say dusty is because that for visible light, right, when we look at something, when we look at the sky, we usually look through the visible light, but we don't look at infrared or UV light. And in this image, it was taken by NASA, and they decided to use infrared wavelength to take this image. So if we are looking at the visible light, it will appears like this. So you can see that you have the 7 sisters, or we call the 7 stars, which are bright in the open star cluster. And this is what we usually take photo of. We usually take photo of the visible light of this Pleiades. But when we switch to infrared light, right, we don't see all the bright blue stars. But instead, if you look closely, all the red stars, the small red stars, would appear much brighter in this image. Why? Because the brighter red stars are the red stars, which is actually relatively older than the blue stars. They tend to emit more infrared wavelength compared to the blue stars, which the blue stars tend to emit UV light, ultraviolet light. So in infrared, you can see the red stars or the old stars better. And as for the colors of these images, right, they have mapped into the visual colors of the red in 24 microns, and the green in 12 microns, and blue in 4.6 microns or micrometers. Okay, so which means that okay, can I click into this? Yes. So which means that this red part over here, all the dust here, they are higher wavelength of the infrared light in the infrared spectrum, and whereas for the blue light, they are lower wavelength in the infrared spectrum. So here comes the question: why can't we see the dust when we're looking through visible light? So we know that because of our human eyes, right, we only can look at visible light, which is like 400 nanometer to 700 nanometer, and other than outside that range, we can't see anything. So if there's a light pointing at us, coming through us at maybe 100 nanometer, we actually can't see anything. So stars, they don't just only emit light in visible wavelength, they do still emit light in maybe gamma ray, X-ray, infrared in this example, or what radio waves, microwaves, blah blah blah. They emit lights in all sorts of wavelength. So if we were to study some stars or some cluster more deeply, we have to utilize a lot of the information that we can get. So in this case, we're turning into infrared, and yeah, we can look at these very beautiful images, which is we can actually observe that there's a dust passing by in front of Pleiades that we actually can't see it if we're looking just through a telescope with our own eyes. So yeah, this is the image for the 19th of February, and I'll move on to the next image, which is the 14th. Okay, so this is actually a special one because the 14th of February is actually Valentine's Day. So yeah, this picture is also titled The Heart and Soul Nebulas because it's Valentine's Day. The day is filled with a lot of love, and so we have this Heart and Soul Nebula. So
And also pink, right?
Yeah.
yeah, so all the pinky red love stuff, yeah. Okay, so how do you actually see that it's a Heart and Soul Nebula? So you know that when we're to look at something strange, or maybe in a picture, when we're looking at the universe, we see something strange. So when we were to name it right, our mind tends to try to name it more creatively, and we will use something or an object that's around us, surrounding our lives, to name it. So in this case, if you rotate this image 90-degree clockwise, if you rotate it 90 degrees clockwise, the Heart Nebula, you can see that this is the heart, the love shape of the nebula, and this is what we call the Soul Nebula. And oh yeah, by the way, this picture is taken by Juan Lozano de Haro, which is a Spanish astrophotographer. And this image is taken at the southern part of the Spain, there's a place called Los Pardilos. Yeah. So what gives off this emission nebula? Because there's a lot of type of nebula, and this type of nebula, we call it emission nebula. So why did this nebula is so bright? So actually is that, nebulas, they are okay, when we were to form a star, right, the nebula is actually the key to form a very new star. So stars, before it forms, the gas of the nebula, they will start to collapse, and gravity will start to pull them each other, and the pull is so strong, and then they'll start to form a new star, a very young and very intense star. So you can see that there's a lot of blue stars which are very, very young compared to all the red ones, and those stars are what gives off light to this nebula. So the young stars gives off a lot of ultraviolet light, and the light from the ultraviolet light, they will hit the hydrogen gas on that's giving us the light of the nebula, because nebula, it consists of mostly hydrogen gas, and so the UV light from the star hits the hydrogen gas, and which means that the electron in the gas, in the hydrogen, will receive one UV light in certain energy, and then the electron will start to jump off its ground state to another level, and then after that, immediately, the electron will fall back to its ground state, and hence releasing another form of energy, which is also light. So the electron, after it falls back, it releases a light, and that light is what we're actually seeing it right now. So we can see that all of this red and very beautiful light from this nebula. And also, the astrophotographer also have edited another picture which is starless. So when we go to study a nebula, it's not ideal that there's a lot of stars around it. Then in this case, we can't really actually study a lot of it about the nebula. So if you remove the star, you can see that this is only a picture, just the nebula without the stars, and we can look at the nebula much more better, and we can study it much more precisely. Yep. So this is the picture for the Valentine's Day special, 14th of February. And then after that, I'll move on to the next picture, which is my last picture. So this is also a quite famous one because this picture is actually about this comet ZTF and Mars. And this comet has been around our Earth for these few months already. And actually, right now, this comet is actually starting to leave Earth. And yeah, it's going to fade away in a few months. So this, by the way, this picture is taken by a landscape and also a night photographer, Donato Laus, which is an Italian. Okay, so there's a lot of beautiful stuff in this picture. So first of all, the comet, yeah, and also if you look closely, this is Mars, and if you look closely, there's a dark nebula over here, and this picture is taken at the Matterhorn, the infamous Matterhorn at New Zealand. So let's give some more deeper explanation. So this comet ZTF actually just entered our solar system in around last month, and it's originated from the Oort cloud, which is about like 1 light year away from our solar system. Which is also it's the Oort cloud is also surrounding our solar system. It's just that it's 1 light year away from our solar system, and so this little comet over here, it came from the Oort cloud, and then it started to approach our sun in last month, or maybe 1 or 2 months before. And actually, last month, the comet came the closest to our Earth, and so a lot of astronomers from the world, they actually tried to take a picture of it, because this little fella over here, it takes about a few thousand or even more than 10,000 years to complete one cycle. So this is actually a very rare appearance for us, because we can't really wait for 10,000 years to take another image again. Yeah. And now actually this comet is already receding away from Earth. So if you all haven't taken the image of this comet, so you guys better hurry or it will fade away soon. And but wait for this comet, if you look closely, there's actually 2 tails coming off it, and also a very bright green glow. So what causes this actually? You may think that the comet will be very, very big. If you were looking at this picture, you think that, oh my god, this comet must be very, very huge. It must be maybe 10,000 or maybe hundreds of thousands kilometers in size. But actually, no. Comets are relatively very small. Their diameter is around 10 kilometers or maybe even less than that. But what gives them this bright glow and so makes them look so big in this picture? So the cause of this green glow, right, is because when the comet approaches our sun, the sun will vaporize the carbon atom on the nucleus of the comet. And so when it vaporizes, it will give off a bright, very bright green glow. And also it will give off this one tail, which is what we call the ion tail. So this tail is actually this tail is actually releasing a lot of gas, a lot of ions. And in this image, we can immediately know that the sun will be below the horizon. based on the direction of this ion tail, because the sun, when it shines on the comet, it vaporizes it, and all the gas will be vaporized in the opposite direction. So it means that the sun must be in this direction, or maybe over here, and the light shoots to the comet and it vaporizes all the gas. And what about this another gas, which is quite bigger and also fatter compared to this? And this is actually another tail, and also what we call the dust tail, which includes heavier particles, and it's also much more, how is it, dustier. Yeah. So when we were to see a comet, when we know how to differentiate its tail, then we can acknowledge where the sun is, and also where the comet is flying. So in this case, the comet is flying from left to right. So yeah, apart from this image of the Mars, we can also see there's one dark nebula over here, and it's basically just a lot of dust and gas, which is blocking away the light of the stars behind this. So in this region, we can't really see the stars behind because it's blocked by this nebula. So yeah, this is it for me, and I shall pass it to the next person, who is...
Will pass to me.
Oh yeah, okay, pass to Boon Wei. Thank you very much.
Okay. So let me share my screen first. I should cancel. Wait. Okay.
Yeah, I can see your screen, Boon Wei.
Okay.
Was so nice, this one.
Yeah, this is very nice, and actually, this is also featuring the comet photo that is discussed by the Sunit just now. So this is the APOD on 21st of February. Taken by the Tara Mostofi, the photographer based in the Yosemite. So this one is the Yosemite Fall, and Yosemite Fall. I still remember last year I did have a pod session to saying about their famous waterfall in which is another waterfall, which is the Hostel Fall that are having a fire fall in a few weeks starting in February also. So the fire fall is actually happen when there is a right moment and the setting sun will hit the waterfall, so it will create a glowing orange and red side. Yeah. So this one is not the fire fall, but I feel is the Tara used the similar method, which is the this waterfall is called Upper Yosemite Falls. So the waterfall, you see the lights of you can see the waterfall lights, stage light. Just actually, this fall was lit by the waxing crescent moon happening during the time. Is about end of the January. Yeah, this image was captured late last month. So, and on top of the waterfall, you can see this one is the Kochap, which is the red giant star in the bowl of the constellation of the Little Dipper. And in last time, it was also used as the precise guide for the equatorial mount alignment as a north pole. And this is the comet. Yeah, just now we already discussed it as it just passed its closest to our planet Earth. The picture was taken, yeah, when it is at the best view because it was at the maximum brightness, and then no stars are brighter than it already. Yeah. So this when taking this uh picture is, I think, is quite adventurous for Taro because he was actually, I think, encounter with a black bear when he bringing his gear, the photography gear down to the bank of the Merced River to take the image. Luckily he was safe and we can see this photo. Yeah. uh then this is also a composite image that Taro he used a stack of the stack of 15 images with the 2 minutes exposure to check on all the stars and then to create the clear image, comet image, and then also bring out all the fake detail, the faint detail in the comet tail, so you can see the green colors and the red colors of the comet. Yeah. Okay. So I will go to my next APOD, which is on 12, 12 of the
Oi, oi.
February. Yeah, this is an old picture taken during 2004 June, um, over Hunting, Nebraska, and this is a very famous I think it's a rare phenomena, but very popular and famous photo that that saying about the mammothus cloud. Yeah, taken by the John Olsen photography. So you can see the clouds are like a like a balloon, like a balloon, or yeah, the mammothus. Okay, so we actually, we all know we have a lot of types of the cloud, and then normally we see the clouds bottoms are actually flat, not like this. And the formation of this is because when there's a moist warm air rises and also the cool air condense, then condense into the water droplet at a specific temperature and also at a specific height. Then when the water droplets grow, right, then the clouds will form. So under some condition, when there is a very high concentration of the precipitation particles, like the ice crystals or a big water drop something, so the saturated air is heavier than the surrounding air, so it sinks back towards the earth, and the cloud pocket is formed like like the picture. So these cloud pockets may occur in a turbulence air near a thunderstorm. So, but actually, it is usually seen after the worst of the thunderstorm that has passed. So, there are commonly held misconception that this, when you see this cloud, means the tornado is about to form, but it's actually form, forming after the thunderstorm. Yeah. So this mammothus cloud is very obvious when the sun is lit from the side. So you can see actually this will be taken in the sunset time. Yeah. Okay. All right. So we'll go to the next airport. My next airport is also talking about the cloud. Yeah, the nacreous clouds, very colorful clouds, and also this is the we also call it as a mother of pearl cloud. Yeah, so the picture is taken by Dennis Lieutenant. He he is an astronomy photographer, and he's now staying in Greenland. Yeah. So aqueous clouds is a type of the polar stratospheric cloud. And this phenomenon is actually very rare, and most common happen in Antarctica. Is the yeah, and also observed in Arctic, Scotland, and somewhere in the North Pole region. It occur mainly at the high latitudes and during winter when the temperature in the stratosphere fall below the frost point. So in the daytime, nacreous cloud normally you won't see like this color. Yeah, it will resemble a pale cirrus cloud, very thin layer clouds that you will see. But in the after sunset or before the dawn, the clouds will diffract the sunlight and then will giving this colorful sky cape. So this APOD was actually taken when Dennis he taken looking south at the 69 degrees north latitude at the sunset time. Yeah, so on 24th of January, he 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 was actually chasing this kind of cloud since he moved to this place and then observed the sky multiple times during the winter, but normally won't see very obvious. And finally he managed to took this beautiful picture. So nacreous cloud is also often lenticular wave clouds and also found downwind of mountain range that induce the gravity wave in the stratosphere. So their formation also maybe will associate with severe tropospheric storms. Yeah, but this very beautiful. Yeah. Okay, so I will go on to my last airport. My last airport is also the Jack TF. So this month we have sorry, this month we have we have so many Jack TF picture because it is very obvious and then the best view month for the comet.
Everyone is having comet fever this few months.
Yeah, this view month is a comet fever.
And we must say bye bye. See you in the next 50,000 years.
Yeah, lor. Now already fade, but we can still see. Yeah, a comet and two dipper, and can you still see the comet? Yes. So we can actually still see the comet. I think I find from some reference that from the nights starting tonight tomorrow, the comet will also pass 5 degree away from the star Kochab, which is this one, and many in the constellation of the Alpha Minor, the Little Dipper, and on the night from in sorry, from night in January 29 to 30, then the comet is past 10 degrees away from Polaris in the considered Alpha Minor. So this is what captured in the also in the late January, which when the comet are in between this Alpha our two dippers. Yeah. Now I think the ZDF is currently at the constellation of the Taurus, and yeah, in the west direction at an altitude of, I think, above the horizon. I'm not sure. Based on this, is about 76. But you can actually find a Orion, and then you can try your luck to see whether you can see ZDF, the comet ZDF. Yep. So this is the last APOD in for me. I will pass back my presentation to
me.
to Dr. Zhong. Okay, okay.
Thank you, Boon Wei.
Yes,
Boon Wei, you
Dr.
can
Chong.
please mute your microphone. Mute your
Yeah,
microphone.
sure.
Thank you. Can see my screen, huh?
Yes, yes.
Yeah, okay, thank you. So mine will be February the 20th. Okay. So the title here says NGC 1850 not found in the Milky Way. Okay. So now I'll make the screen smaller. So it's a kind of a star cluster somewhere in our Milky Way. So the credit is from NASA, ESA, European Space Agency, and Mr. Paul Goodpulley. It's a kind of what they call scientists working in the SCSCI, which is our Space Telescope Science Institute, which has been controlling Hubble telescope and the James Webb Space Telescope. But the processing is by our Dr. Mehmet Hakan Ozarek. He's quite famous, you know. He processed a lot of pictures by Hubble and by James Webb Space Telescope. Okay, processed by a Turkish medical doctor. So basically here, you see a star cluster here and another star cluster. So the big star cluster is about 50 million years, light years away, old, and the smaller one here is 4 million years old. And it's not found in the Milky Way because there are no other star cluster in Milky Way have the properties of these two star clusters. So it's a kind of a unique thing. All right. So it's on the borders of this large Magellanic Cloud in the southern hemisphere. All right. So okay. So we go to the next airport for me, which is on the 18th of February. Beijing. Okay, so it says here, Bart Spiral Galaxy NGC 1365 from Webb. Remember, we were already telling ourselves last year that in the coming airport session for the coming year, 2023 and the future, many of them will be what? Webb. James Webb Space Telescope. Previously it was Hubble. And of course, we prepare ourselves that the report from the China Space Agency that the China Zhuntian Large Space Telescope will be launched hopefully by this year. So in future, we also have to present pictures by Zhuntian, China Large Space Telescope, which is flying next to our Tiangong Space Station. So we wait for pictures from Zhuntian in future. So basically here you have a picture of a galaxy, and it's from Webb. That means it's an infrared picture, infrared, and it's a Bart spiral galaxy, and it looks different because it's in infrared. And credit is of course NASA, ESA, and CSA. CSA is our Canadian Space Agency, and it's from one of the National Science Foundation lab called NOAA Lab, and by Janice Lee. I try to get information about Janice Lee. She looks like Asian, you know, could be a Malaysian, you never know. Janice Lee is a person, is a chief scientist in NOAA Lab, and the processing is by Alicia Pagan from Space Telescope Science Institute, right, which is also controlling Hubble. So it's about 56 million light years away. All right, and what you call, basically you can see that this one is Bart spiral galaxy, 200,000 light years in diameter. That means similar to double the diameter of Milky Way. Milky Way, we know that Milky Way is a vast-spiral galaxy similar to this vast-spiral galaxy, but double the diameter of our Milky Way. Right? So you see a lot of stars here, but this is taken in infrared. Okay, so go to the next picture, which is to be presented by our Mr. Lai. Pass over to you, Mr. Lai.
Okay, so yeah, Dr. Chong, stop sharing your
Yeah,
screen.
sure, thank you.
Okay, so my turn again. All right. So yeah, 16th of February. All right, the title name the Hydra clusters of galaxies. So the Hydra cluster of galaxies. So this is actually a clusters of galaxies. That means a group of galaxies. All right, and this image is taken by Marco Lorenzi. All right, and the text is actually a poem generated by this Chat GPT. So Marco Lorenzi is an Italian astrophotographer. Currently live in Singapore. All right. So a lot of his planetary images is taken from his rooftop in Singapore, and all these deep sky images. All right, this deep sky object is actually he remotely control observatory in Chile, and all is taken by the telescopes in that observatory. All right, and the poem below here is actually generated by this Chat GPT. GPT stands for Generative Pre-trained Transformers. It's actually a chatbot developed by this company OpenAI. And this
Very,
Chat GPT, I think recently is quite famous, right?
yeah, very famous.
Yeah.
Yes, I think this Chat GPT go join the interview of Google or something like that, right? And
I thought it's
pass,
Microsoft.
yeah, something like that. I don't really
I
very
think I
remember
think
about
it's the
that.
Microsoft. That's why they are saying actually Microsoft will beat Google in one day. I'm
Yeah,
not sure. I'm
maybe I
not sure.
guess.
I'm not
Maybe
sure.
maybe in future one of my Apple presentation is presented by Chat GPT lah.
Yeah,
Yeah,
maybe.
You can
maybe one day our APOD session will be this monopolized or be dominated by this AI. So yeah, nothing is irreplaceable nowadays because computers can do a lot of works. All right. So yeah, let's proceed with today with this APOD on 16th of February. So it's actually galaxy clusters, all right, named the Hydra clusters, which consists of about 157 bright galaxies. So all these, all right, this one, this bright thing, all right, the long one, the circular one, all right, all these are galaxies, all right, are galaxies. And the interesting thing is this is actually if we look with a telescope or normal telescope or our naked eye, all right, is located at the constellation of Hydra, right, the snake, right, Hydra, and then you will just realize that it's actually just like ordinary stars. It's just a dot, right? But if you enlarge many times, you're able to see this with long exposure. You're able to see this, all right. So these are galaxies. Each of these are galaxies. Okay, so the Hydra clusters is also known as Abell 1060. So it's a galaxy cluster that contains about 157 bright galaxies. All right, and it's in the constellation of Hydra. So the span of this Hydra clusters is about 10 million light years. That means from this point to this point, all right, it's about 10 million light years. And the interesting thing of these Hydra galaxies is actually it consists a high proportion of dark matter. And this Hydra galaxy is about 158 million light years away from Earth. All right. And there are three large galaxies inside these Hydra clusters. So of course the largest, all right, is the is a vast spiral galaxy. Uh, it's named as NGC, New General Catalog 3312. All right, it's a spiral galaxy. All right, NGC 3312. And the another two largest galaxy is actually elliptical galaxy. All right, not this two bright one, not these two bright one, but it's the two over here. All right, which is NGC 3309. All right, NGC 3309 over here and NGC 3311. right? So NGC 3309, 3311, 3312 is the three largest galaxies in these Hydra clusters. And another interesting part of these Hydra clusters is this NGC 3314. All right. It's actually a superposition of two galaxies. All right, two Mars pirate galaxies. All right, that means over here we see like it's actually one galaxy. It looks like just one galaxy, but actually there are two galaxies behind. All right, and the two galaxies in this NGC 3314 is not related to each other. It means both of them are two separate galaxies. All right, so these are about the Hydra clusters, all right, taken by Marco Lorenzi using remotely controlled observatory in Chile. All right, so next I'll proceed to my last APOD, which is the 15th of February 2023. So this is a beautiful picture. All right, this image is quite beautiful. Wait, change again. Why it does not appear over here? Okay. So can see.
Yes, can see your picture, right?
Okay. So NGC,
Oh, nice.
sorry, not NGC. It's the Aglo Sky over France, taken by Julien Louton. All right, Julien Louton is a French photographer. All right. So over this image, there are a lot of objects. We have planets, we have nebulas, we have star clusters, we have a Milky Way, and we have the atmospheric phenomena, which is the air glow. And this image is taken in Château de Los in France. All right. Uh, so let's see this image. All right, it's beautiful. We have air glow. All right. So what is air glow? Air glow is actually the atoms and molecules in the upper part of our atmosphere excited by the sunlight, and after it's excited, all right, to return to the original state or the relaxed state, all right, it have to emit photon. So the light is actually the light we see by the photon released by the atoms or molecules in the upper part of atmosphere is the air glow. And air glow is actually very dim. The brightness is about 1/10 of a brightness of a star. So you need if for imaging you need a longer exposure to observe this air glow. Or if you are in a totally dark or completely dark area, maybe you can see a very dim air glow. Or another option is if you fly near to space, then you might able to see this air glow. Okay, so it's more or less like aurora, but the difference is aurora is actually generated by the high energized solar wind, but air glow is actually caused by this ordinary sunlight radiation, solar radiation. So this is the difference between air glow and also aurora. So over here we have the Milky Way, the arch, right? We can take Milky Way in many places, including in Penang. All right, Balik Pulau is a good place. All right, and I believe that day members night maybe we can take this Milky Way from Chunkiat Observatory or somewhere or some dark places in Penang.
I
Alright.
think somewhere in the paddy field can do good.
Yes, yeah, it's not difficult to take Milky Way, right? And then we have Mars. All right, it's very easy to recognize Mars in the sky because he's the only red planet. So you see some red stars is most probably if it is a planet, then it is Mars. All right, and the famous Orion Nebula, the Sirius, the brightest star we can observe from Earth. All right, and we have Andromeda galaxies, the Pleiades star clusters. Pleiades, I think someone present just now, right? I think is Sunyit. Is it Pleiades?
Yes.
Yeah.
Yeah. And then yeah, we can observe Pleiades from Earth actually. Always in the stargazing in Kapasing Drive. I think even for last year, I think end of the year, December and early of the year, November, December, January, we can observe this Orion. We can observe this Pleiades, and observe Pleiades through telescope. We can see there are many stars, right? Many small stars, all right, through the telescope. But actually, it's not small. All right.
One
So
question. Okay,
sorry.
continue, like.
Yeah. So Andromeda galaxies, all right, is one of the closest galaxies from Earth, all right, and one day it will collide with our Milky Way, all right, as predicted. So this will happen, all right, maybe about 4 billion years later, and after colliding with this Andromeda galaxy, Milky Way and Andromeda galaxy collide, all right, we will form a large elliptical galaxies, all right. So this explains how a large elliptical galaxies which we see just now, the two large elliptical galaxies in the previous epoch I present just now, how it was formed. So one day we will be in a large elliptical galaxy. But don't worry, all right. What happened if both galaxies collide? All right, don't worry. By that time, actually, our sun will be turned into a red giant, and the diameter will eventually swallow up our Earth. So you will not able, or you will not have chance to experience that, right? Uh, what will happen after both galaxies collide? But there are a lot of hypotheses that mention about what happened after both galaxies collide, and it's interesting, right? So if you are interested, you can go to search for more information what happened after both galaxies collide. So that's all for my presentation
One
today.
quick question, live for this picture.
Yeah.
The house in front, is it Harry Potter's house?
This one, I don't think so.
Yeah.
Because Harry Potter is
It's in
is,
England, ma.
is
That's
in
why
England,
it's
right?
England. This is in France.
Yeah, this is in France.
Very nice house.
Yeah. Dr. Sean, when you were in Grenoble, you went to this place before. Is
No,
this
no.
place near to Grenoble or what?
Yeah, quite far away, quite far away. Actually, this is a manor, not a castle. You know, a manor is a building, small personal occupation area, smaller than the castle. But in France, they are everywhere. You have manors, you have castles, and so on. Yeah, okay.
Okay, so I'll pass over to Dr. Chong to continue the following APOD presentation. And Dr. Chong?
Yeah. Thank you, Mr. Lai. Okay. So my next airport is this one, which is on the 10th of February. Can you see my screen? Yeah. Right? Can you see my screen?
Yeah, we can.
10th of February. So we says that ZTF again we have ZTF. Every time ZTF. The comment lah. Okay. ZTF is our what they call transient facility a telescope to look for such object. Need Atlas. So ZTF is a comet. Atlas is also a comet, but they are different parts of the solar system. So we know that this Atlas passed closer to the sun earlier, right? Then later on, our ZTF passed close to the sun. So in this view, you have both ZTF and both Atlas, and both are green color because in the coma of the comets, you have this diatomic carbon and cyanogen. Cyanogen is CN, CN, which is like hydrogen cyanide. So, oh yo, hydrogen cyanide, did I say? Yes. So if the Earth were to pass through the previous location where the coma of these comets were, that means the Earth will pass through this cloud, which is poisonous. Cyanide, poison, So luckily we didn't pass through it. Remember, in the early 20th century, when the Earth passed through the head of the Halley's Comet, many people in Europe were wearing the face mask, like the one they go for war to avoid those poisonous fumes from the comet. So luckily we didn't pass through. So you have both comets in the same plane. But of course, the ZTF is much brighter, more spectacular than Atlas. And both of them are bye-bye, leaving the inner solar system, going out of the solar system, and we'll come back later. All right. So this is taken by our Stefan Bermel, a German astrophotographer, taken from Bavaria. Remember, Bavaria is one of the famous province of Germany, southern Germany. All right. So this is our 10th of February. ZTF, Comet ZTF meets Comet Atlas. So the next one is February the 5th. Now, this is said Enceladus by Saturn shine. Remember just now Mr. Rai presented his picture of Iapetus, the full-face moon of Saturn. So this is another moon of Saturn called Enceladus. So this is famous because many years ago, the Saturn mission, the Cassini mission, have flown by orbiting Saturn, flown by many of the moons of Saturn, the large and small one. So they call it the tiger stripe moon. So a lot of these stripes here, right? You have this green color, so this tiger stripe moon. So basically by Saturn shine, meaning that the sun is on the right side, the sun light pass by the Earth, pass by the Mars, pass by Jupiter, and fall onto the main surface of Saturn. And the light will scatter off the main so no surface lah, the atmosphere of Saturn, and scatter back to this what you call Enceladus moon, and then it scatter back to the Earth. And you can see all these things, all this canyon. So basically, this is a very cold object, and this canyon here is about 1 kilometer in depth. Very nice. And this on the right side, of course, the direct sunlight from the sun falls onto the moon. This Enceladus, and taken by NASA, ESA, JPL, Jet Propulsion Laboratory, and of course Cassini imaging team. And of course this composite is done by Gordon Olgakovich. Okay, so it's a well-known amateur image processor from Croatia. Remember, Europe got many small countries now, and this is a small country called Croatia. And Croatia, we know lah, famous for football lah, World Cup football, recent one, they did well. You bring in football now. So this is the what we call the moon of Enceladus of Saturn, and this is Saturn shine. Remember, like Mr. Ryan mentioned earlier, that Saturn now has 83 moons. Jupiter has 92. So the planet with the most moons is Jupiter. And so our solar system now has 224 moons. So many moons, but sorry, our poor Earth only got one. And even poorer, Venus and Mercury have no moons. But at least Earth got one. So in future, I meet aliens someday walking on the beach in Batu Pergi in Penang. One of the questions is, how many moons does your planet have? Like this. So now the humanity has been discovering a lot of exoplanets. We're waiting for the big discovery of the first exomoon. Some of the exoplanets with our very sensitive technology, telescope technology, is possible to detect a moon orbiting the exoplanet, which is orbiting the other star. So we're waiting for the discovery of exomoon. All right, but this is for our solar system, Enceladus. All right, the moon of Saturn with the tiger stripe. All right, and then this is taken in the Saturn shine. Okay, so my next picture would be the 5th of February. That's the 5th already. Next one is 3rd of February. And guys, the same thing. Again, you have ZTF. All right. So this is taken by our David Ibarra Gomez, what you call an engineer from Spain. And then he took this picture, long exposure, a few hours. And so we know that in Europe, you have here the Polaris. All right. But I thought Polaris in the center. No. Polaris is a bit offset about 1 degree from the exact North Pole of the Earth. So a bit off. And see, the tail of Polaris is shorter because it's near the North Pole, so short. But then you have this long one, which is the tail of Comet ZTF. The green globe is extended because it's a long exposure. And then you see many of the stars got star tail. And because the Comet ZTF is got the coma, the head and the tail, so you see like very blurred image. But all the other stars are thin stripes. So these are star tail, and also a trail of Polaris, short one, plus Comet ZTF, all right, and taken by Ibarra Gomez, astrophotographer from Spain, right? So I really like this picture.
This image actually looks a bit special to me because all the time when we see these star trails and Polaris is at the center, but this time this Polaris is not in the center. We see the Polaris trail.
Yes.
Very rare we see Polaris trail.
Yeah. So actually, if you have a powerful telescope in Malaysia, you go Langkawi, you point at this Polaris. If you look carefully, you take shots, you find that at certain time, the Polaris dots, dot orbiting around here, a small circle around the actual celestial North Pole. right? This Polaris, right? And what do you call this one? So we go to my last airport picture, 1st of February. This one is interesting. Now, this is the 7th world of TRAPPIST-1. Okay, what is 7th world? Is the exoplanets, right, of the star TRAPPIST-1. Okay, so we know that many years ago, about 6 years ago, everyone was talking about TRAPPIST-1, TRAPPIST-1, TRAPPIST-1. That means a star in constellation of Aquarius, and using a telescope in Chile, the European astronomers discovered that you have altogether 7 exoplanets. Okay, so basically, if this is a star, it's a Jupiter-sized star, very small star, TRAPPIST-1, constellation of Aquarius, and you have 7 exoplanets orbiting. Now, be careful, do not be misled by this picture. Oh, actually, you're on one of the moons. No, this is a space art painting. Because TRAPPIST is very far away, many light years away. So this guy, well-known American, Michael Carroll, a space artist, a male space artist, painted a space art painting. So you have here the star TRAPPIST-1, a Jupiter-sized star, all right? And then there you have the first exoplanet or the orbit is 1, 2, 3, 4, 5, 6, and 7 is this this moon itself. No, this planet itself, right? So 7. And one of them, the fifth one, I don't know which one, the fifth one, this one or this one, can have liquid water on it. So interesting. But this is the 7th moon. So this is the 7th moon of the TRAPPIST-1 exoplanet system, where there are 7 planets. Right? So this is a very big discovery. Right? So a bit about how you name the exoplanet. So in astronomy, we follow the convention, like this is the star called TRAPPIST-1. So the first planet is called TRAPPIST-1b. There's no A. TRAPPIST-1a is the sun, the star itself. So we don't call it TRAPPIST-1a, the star. We know that TRAPPIST-1 is a star. So the first exoplanet is TRAPPIST-1b. Second exoplanet TRAPPIST-1c, D, E, F, G, and this moon is H. So this is how they name, right? So now next one in future, when I go meet some alien walking on in Batu Tinggi, ask them is, wow, your star got how many moons, how many planets? So our solar system now have 8 classic planets, from Mercury to Neptune. So our solar system record has been broken. The exoplanets have already seen recently that one of the stars in the Milky Way has 9 exoplanets. Has been broken. So don't be surprised in future. You see the movie, the science fiction movie, that there's an alien come to the Earth and said, "I come from this star system, and my star got 25 moons. My star got 25 planets, exoplanets, but our solar system only got 8. This one got 7 already, and the record has been broken. All right. So now is over for this presentation for today. So maybe I'll just present the closing remarks. Before that, any comment by any one of you here? Closing remarks?
No questions found on both Facebook and this YouTube page, right, and YouTube channel.
Yeah.
But I have one question for Dr. Chong just now when you mentioned about, you said the helicomets and then the Europeans are wearing the face mask. Is that really that dangerous?
Actually, this was this story in 1986-87. The last previous appearance of Halley's Comet was in Malaysia, 86-87. We were able to see Halley's Comet for 7 months, right? In the end of 86 and 1987. So that time the news was that in the previous approach in the early part of the 20th century, the Europeans were wearing the face mask like they go to war, that they discovered that using spectroscopy from the spectrum of the Halley's Comet, they detected what I call this CN, cyanogen, like hydrogen cyanide. But the answer to life's question, no, it's safe, because the coma and the tail of Halley's Comet, that's CN, hydrogen cyanide, but very thin, very thin. But even if the Earth were to pass through the previous location of the comet, and then part of the CN poisonous molecule hits the Earth's atmosphere, but the amount is very little. But there is CN, cyanogen radical, so that cyanide, So in other words, if I were you all, if you make a movie like that, you make sure that the movie director got the science correct, his astronomy correct. They show the mankind, one man and woman astronaut land on the comet through the green cloud of the diatomic carbon spectrum and also the cloud of cyanide cloud, and they go there and they do something which is dangerous. They open their face mask. Dangerous. There on the comet, very thick concentration of cyanide, So imagine that the what do you call this? Halley's Comet got a lot of cyanide, which is sublimating from the surface of the nucleus of the Halley's Comet. So sublimating means from a solid material, ice, cyanide, to vapor, not going through liquid. So there's a lot of it near it. So imagine that you are now taking all the cyanide on the surface of Halley's Comet, evaporated, and smear it through the atmosphere of the Earth. Then gone lah! Armageddon for the Earth. But luckily, it passed through the previous location of the comet, very thin. So I doubt it's dangerous. But there in Europe, you check the story, in the 1910 appearance of Halley's Comet, many people in the world in Europe, they wear the face mask. That's it. So in other words, in astronomy, anything can happen. Anything can happen. But any other comment, question?
So far, no comment from both sides. So maybe we can do closing.
Yeah. So closing is, thank you, Mr. Lai, for presenting Sunyi and our flower Bunde for presenting.
Thank you, Dr. Chong.
Okay. And of course, a bit of wrapping up is, so recently our ASP, Associated Penang, got activity. Look at me, got sunburn, We just spent yesterday night and this today in the Tasik Village resort there. So the sky was not to say very clear, but from time to time, you see a lot of stars come up. You're very lucky. So Chiken set up his telescope, and our member Jiri, all right, set up the telescope, and our Dr. Jiva showed his Veonis Vespara telescope. Very simple, very friendly. So just sit down there quietly, and Wi-Fi from his handphone to the telescope can take many deep sky objects. So very, very impressive, The Veonis Vespera telescope. So guys and girls, prepare for the future. That means future is what? You put a telescope on the ground, no need to do polar alignment. No need to do everything, all automatic, controlled by handphone. And within 10 minutes, if the sky is clear, you can get what? Horsehead Nebula. Omega Centauri public cluster. Like that, So this is going to be a revolution in astronomy. So we hope that Dr. Jiva also said that he can lend us another of such a telescope, the unistellar equinox, to bring it to Kapasing Drive. So Sunil, get ready, Sunil. We can fly this type of telescope in Kapasing Drive. Where? From Kapasing Drive, one take Horsehead Nebula, Andromeda Galaxy. So the thing is taken, recorded by that telescope. It's only 2-inch aperture. The processing is done automatically by itself. And straight away, the answer within 1 minute pop out, come to your handphone. And when we do that, maybe we have a projector project into a screen next to our telescope in Kapasing Drive. So it's going to change astronomy. So as I said, I made a comment in our WhatsApp group that in future you can see an 80-year-old grandma, right, who only know how to use the handphone and don't know what's called plate solving, polar alignment, don't know. But just put there and it will align all by itself. And then plus, I want to go to this Malaysia object 44, and they do it and can get the result. And with the handphone and with a crowd of 30 people, you can send the picture to everyone in the crowd or on the projection. So this is going to be a revolution in astronomy, So astronomy is going to be never the same again. And this company, 2 companies are from France, So we expect more of such companies to come into the market in future. And like from China, they'll come, sure it'll be cheaper. So this Venus Vespera is very user-friendly telescope, 2-inch aperture, right? And you look at it now, when the first I saw it, I thought it's a kind of makeup set of my wife, so delicate looking. It doesn't look like a telescope, but it works, so impressive. So I hope we can borrow one of another one, which is a bigger one, the Unistellar Equinox, which is a 4.5-inch aperture, bigger one. Our Dr. Jiva said we can borrow from his. Of course, he also donated us another set of equipment, but he can loan us his bigger robotic telescope. We can try and capacity drive. Fantastic. It's a real eye opener. Okay. Okay. The other one is we hope that more activities will come for police. So guys, girls, so you can come back 29th of April, Saturday, 30th of April, Sunday night in Perlis, near to the place we did stargazing in Perlis 3 years ago, YB Gun Island, right? And of course, our society SP, we're going to conduct again for this year, astronomy quiz for Penang Primary School. We alternate. Last year, 2022 was secondary, so primary. So we don't know, can help us lah. Question.
Yes, that's not a problem for me. I can prepare the questions. I will send the questions back through emails, maybe.
Yeah. So of course we will hope our member, Dr. John Su and Dr. Idawati from the ASEAN can also help us to prepare questions. Another one is we want to conduct our astrophotography contest for 2023. Getting popular. So the pictures of our past astrophotography contests are getting better and better, for standard, right? Okay. So that's all from me. Okay.
Yeah, and just to add on that we are actually resuming our stargazing session in Kapasing Drive.
Yes.
In Saturday on Saturday, right?
Yeah, because Saturday night we were in this Pasir Beris in Kedah. So coming week, I think we don't have anything else. We'll be Kapasing Drive. All right.
Yeah. So we welcome everyone to join us in Kapasing Drive.
It's open to everyone.
Yeah.
Next to the 4 pillars of Kapasing Drive, Saturday from 9 p.m. to 12 midnight. So we hope. So I don't know whether our Sunit can be with us to join us. We put at least 1 or 2 telescopes. Get our bursting of excitement in ourselves with the people of Penang.
Yeah, I can join.
Yes. Okay. So that's all for me. Any final comments? Anyone?
No, I think that's all. Anything from Sunit or Bunwei?
Nothing.
God, sorry for the loud music just now.
No, it's okay.
It's okay. All right.
Yeah.
So I think that's all for tonight. So once again, thank you everyone for joining us tonight, and we wish you all have a nice night. All right. And tomorrow is Monday, so have a good rest and prepare for tomorrow Monday's work. All right.
We're waiting for images from Zunjian 2023.
Yeah. So thank you everyone. Good night. Bye bye.
Bye.